Good evening, everybody, and welcome back to this series which we are doing on particularly rate analysis. And basically, we took the case of probably initially earthwork. We saw that earthwork had some niceties. We needed to look at it based on the way the cost is going to be incurred. So 0 to 1.5, not much cost. As you go deeper and deeper, you are going to wind up with a lot of probably things where you look at safety of the employee, you look at probably the dewatering needs, which are going to be very important, especially when the winter, when the monsoon starts, so on and so forth. We went for the concrete works. We took the concrete the example of calculation of concrete from the footings. Footings are very good examples for concrete works because whatever you have in the footing, typically that's the same thing that's there everywhere. And what are the things that you go for footing? We that was probably what we saw in the list of things which are done. We need to have reinforcing rods. We probably make a PCC base in the for the footing. And moving on, we also have a few other things: the cover blocks, the shuttering board, and so on and so forth. You pour the concrete, we need probably some mechanism to lift the concrete from wherever it is being mixed to the place where it is poured. Then we have to vibrate it. And the other important things probably which we are not spoken about is curing. So are we going to use curing agents? Are we going to use moist curing, or whatever is the technique which you're going to use? We can use it, but very importantly, we should remember that each of them comes at a cost. And moving on, concrete, especially in the basement, needs to be protected from water. So we may use different kinds of waterproofing techniques for ensuring the concrete is safe. All of these are going to be a very important aspect in the rate analysis, because even if one is missed, the cost is going to escalate a lot. And in the previous session, we had the shutter, which brought us to a very important concept of reusing the shutters. Now, if you see, I have got a picture of a construction site, and in this, we are seeing the material being simply dumped. Okay. Now, the issue here is, if you see in the background, excuse me, just a minute, my pen. Yeah. So if you see here in the background, we see that all the couplock system has been very nicely arranged. Okay. Now the shutter board has not been too neatly stacked. Of course, it's very difficult to stack this, but most of what you see is the small pieces which would have been used for covering up all the gaps which would have been in the shutter. Okay, so you would have had a regular board, and this particular contractor actually has his own system for shuttering. That is, he makes a shuttering board, and that is a separate vertical of his business. So you know, the main point which I want to share here is that the material, although it looks, I mean, like this material is very randomly stacked, but if the material is stacked like this, you will not be able to find a particular piece comfortably. Okay. On the other hand, suppose you are going to have very good housekeeping systems which are going to point as to where this material is kept. You can very easily identify, and then you can get them and then start off your work very quickly. Okay. Now, if you are not maintaining material properly, the cost of the product of the material goes up. Why? Because when you are looking for a particular piece, that piece might be missing, or it might be in short supply. It may be in short supply because you are not keeping it properly. Maybe if some of the shoring material and some of the associated is buried under this pile. Okay. Although inside the site you may have the required, say, 1,000 pieces, 300 of them might have got lost because you have just carelessly kept up. So on the day you are going to do your work, it's going to look like it's missing, and when you're ordering in the short run, your rates are all going to shoot up. Okay. Now enough of the previous class stuff. Yes, so yesterday especially we were looking at what we called as repeatability. So the more repeatable some operation is, the greater is your reduction in the cost, because you don't buy new material. Again, there might be some maintenance. So if you maintain properly, that means the product is not going to get what you call as give a sense of not being usable. You will be able to use it probably more number of times, because the quality is still maintaining. The other important value is whether there is any salvage or scrap value. So many times your shutter board might not be good for your operation, but some smaller contractor, instead of spending the 100% of the cost, he may be willing to buy it at 40% or 50% of the cost. So you still do not lose as much money as simply having to throw it off. So for example, if you are looking at plywood shutter, you may not be able to use it more than two or three times, and you will not have much resale value. So you will prefer to go, if you are having sufficient number of repeatable operations, you'll prefer to go for a material which is having higher repeatability value. Moving on, if you remember, we were looking at the 3D model over here. So if you look at this, you see that there is a plinth beam, there is a column, and there is a um, footing pad. Okay, I'm just trying to introduce to you what we will call as some approximate method of analysis. Okay, so approximate method of rate analysis. So what is this approximate method of rate analysis? Maybe it's better to introduce the concept first before I go much further. So when you are going to go for a project, you may not have enough time for doing an accurate analysis, and people may not be also very much interested in an accurate analysis. Going this way, that way, they are not bothered. So but it should not be so off that the person themselves don't feel comfortable with the price which you give. Okay, now coming here, if you can see over here, this is the footing pad. So this is a combined footing over here, and this is the plinth beam. Okay, this is the plinth beam, and here we had in L&T we used to call this as the bathtub approach, where the entire, I mean, at least in our vertical we used to call it. So I don't want somebody to tell me that no, this is not what we call it. So suppose you want to have an excavation, and you are seeing that there are a lot of small columns closely spaced. What we do is we prefer to just take the entire area as a mass excavation and remove the entire soil. So the entire place becomes an excavation. So this is what we used to call a bathtub approach, and that is what is happening over here. And for that reason, you'll find that the plinth beams and everything looks very high up. Okay, and this is called as a dowel. So some other there will be some other extension or some other beam coming up later. So you can see the dowels on both sides. So later on, this beam is going to come in. Okay, now probably small, I mean, like I can say that I can share with you one thing which was very admirable here. So when the backfilling operation had to be done, they used a small bobcat to go in. Bobcat is one of the equipments, small way by which you can probably carry a little bit of soil and also move it around. And the bobcat could actually go inside this entire area, pushing the soil wherever required, getting the whole thing done. Okay, now coming back here, so you can compare the 3D model which we have here and also the drawings, I mean the photographs which we have here. Hopefully they are going to make a lot of sense. So here we are trying to see what are the elements which are here, and we are going to try to very quickly try to see what kind of methods we can use to very quickly qualify a cost. Okay, I will stop here for a minute and ask if you have any questions. If you have any questions, I request you to please ask.
Hello.
Yes, please.
Hello, sir. Actually, sir, in the last diagram,
Okay. Photograph or diagram?
sir,
Yeah, please tell me.
Sir, my question is, sir, that this highlighted beam in a violet color, is that tie beam, sir?
It's actually a plinth beam. It serves as a tie because when you look at your analysis, your column should have minimum unsupported length. So because this tie beam is there, because this tie is there, it reduces the unsupported length, and also this will be used as a what we call as a lintel, so that a wall can be raised on top of this. Okay.
Sir, so this beam is not designed, means we have to just put it after the completion work, right?
No, not necessarily. Not necessarily. See, I will probably another thought comes to me. So, if you look at this, these beams are very high up, right? Okay,
Yes,
but
sir.
the plinth beam on the periphery are typically kept at a lower level. The reason is, there's a reason. When I'm going to backfill the soil over here, and if suppose the
Yes,
beam on the exterior is also at this level, it means that all the soil which is inside will flow out of the basement of that
yes, sir.
building. So typically the plinth beam which is in the outside is kept at a lower level. This is just a general thing which I am telling you. This is for the benefit of the structural engineers who will be working out the layout which is present here, and also for the construction managers. If you find that the plinth beam is not sufficiently below the ground, okay, that means you will not be
Yes, sir.
able to raise this brick wall. If this brick wall is not raised, that means you cannot do any backfill. If you do backfill, all the soil will float. Okay, now for
Yes, sir.
to your question, the short answer is that these beams are required to be done, and it is ideal to be done as cast at the same time as the rest of the building. Over here, because I want access, that is why this beam was not completed. Do you get the point?
Okay.
Okay.
Yes,
See,
sir.
now if you see, if I'm going to be able to take a small bulldozer inside this site, don't you think I'll be able to move more soil? That is the reason why they initially did it like this. Do you get it? Because even if I fill the soil, I should not take a lorry on top of
Yes,
this beam, because this beam was not designed to carry a lorry's load. Got it?
yes, sir. Yes,
Right.
sir.
Any other questions? If not, let me go on. Okay. Anyway, thanks a lot for the question. Moving on,
Thank you, sir.
we need to we are trying to find out what is the rate. I mean, like what is the quantity very rapidly. Only if I'm having the quantity, whatever is being put in a table, okay, like this one, the table over here makes sense. Otherwise, the whole thing is not, I mean, like, it's not going to be relevant at all. So now I am going to yesterday's calculation. So for now, we have the footing as 20.5 for F1 to F4. And F1 to F4 probably is the more important, I mean, like, they are the only things in footing. I am now coming back to the drawing, and if I see here, I have columns. The columns are typically 250 by 250, except for C3, which is C3, which is 250 by 600 mm. Okay, and do I have the entire overall height of the column? Yes. Can you see we have the overall height of the column? Till the roof it is 11.15. Okay, and from where does it go? It goes from the uh, minus zero point 0.5, and then this level is not being clearly defined. Okay, you can see that it is given over here minus 1.95. So what is the typical depth of the footing pad? It is 300 mm. Okay, footing pad, all the footing pads are 300 mm. So what would be the total height of the column? The total height of the column will be 11.15 plus, okay, plus 1.95 minus 0.3. Okay, so if you have a calculator, I strongly recommend that you try this out. Bottom of the footing, this is the founding depth is minus 1.95, and in addition to that, we are also having a PCC, so that is 0.075, that is 75 mm. So this actually gives my height of column as 12.725. Okay, and now coming here, I have three columns, and what I'm going to do is okay, let me just use the same guys. When you are doing this, I kind of expect that the whole thing is done on the standard sheet. So as of now, maybe I'm not doing it on a standard sheet, but bear with me. But don't use that as a excuse with me. I am not keeping the remarks. So yeah, maybe, but because of the ease with which I can do this, let me give the remarks. And yeah, so we got remarks over here, and yeah, so I got oh sorry, this is the description. Right. So here we are going to use this is almost like a continuation of this table. Okay, although it doesn't look like a continuation of the table, bear with me. It is going to be the same. It is going to be concrete over here. So concrete in column C1, C2, C3 and C4. Okay, numbers is let us quickly go back to the drawing and see what are the number of columns which we have. It is not required that the column the numbers have to be given in this. You will have to physically, in all most of the cases, count the number of columns which have been given. Okay, now one of the things which we tried to do is keep the same number numeration for both the column and the footing, because I could have very easily made this as where is C2? Yeah, I could have made this as C1 F4. Okay, but we prefer to keep the same name so that when you're doing the quantity and other things, you are having lesser ambiguity. Okay, and it also gives me the freedom. Suppose I need to change it at some point in time, it is not too tricky. Okay, it so happens that we are having the numbers marked over here 25,343. So I'm just going to be in a position to use this. Okay, let me probably use purple. 25,343. Okay, now the height of the column in all these cases is 12.725 meters. Okay, now one very important observation, one very important thing which you should do is remember is, had the footing pad been deeper in some of the cases, the height will not be the same. Okay, and we need to be a little cautious on this, because if suppose I'm going to take the measurement twice, that means the amount of concrete is actually more than what you thought it was there. And if I'm not mistaken, all the columns are 0.25 by 0.25. Am I right? So let me just have a look at it here. Yeah, all the columns are 0.25 by 0.25, and except for this C3, which is 0.25 by 0.6. So let's go ahead. 0.25, 0.25, 0.25, 0.25. If one of you can just give me the volumes, it will be very good. So here it is 0.6, 0.25. Here again, length into breadth doesn't make much of a difference. But if you ask my personal preference, I will be looking at the x and z coordinates, and x and y coordinates or x and z coordinates. Because of StatPro, I'm kind of using x and z, and it will be a consistent way by which my BOQ sheet will look, where I have the x and z based on the orientation in stat. It need not be the same thing for a site person. A site person can do according to their convenience. In any case, there should not be repeated measurements. Okay, going on, 0.25 by 0.25 into 12.725 into 25. So this is coming to 19.88. I'm just taking it as 20, and then we are having this one, three numbers, which is coming to 2.4, and again this will be, this also I'll take as 2.4. Then we have four numbers of 0.6 by 0.25 into 12.725, okay, which is nothing but 7.7 meter cube. And moving on, another very important thing which you will have is the beams. Okay, and if you look at the floor plan, yeah, so if you look at this, we are having 1, 2, 3. In addition to this, we got some secondary beams also provided over here, and I'm not sure whether I gave a picture of a secondary beam. Okay, so we've not got a picture of a secondary beam. Give me 1 minute. Let me just see if I can very quickly get a photograph of secondary beam, because I wanted to keep that. Right. So this is an example of the secondary beam. So in the building which we have got in Revit, it would have looked something like this. So here this is the primary beam and this is a secondary beam. There are two advantages. Two-way slab has been made into a one-way slab because this beam is there. And which would be the spanning direction? This beam would be spanning in this particular direction. So as a construction manager, if you are finding that the reinforcement placement pattern is suspicious, because the secondary beam is present, it cannot be a two-way slab. So immediately you can raise your concern to your boss, and then they can take it up to the design department. So these are all small things which probably all of us need to try to make ourselves familiar with, right? Now moving on, so this particular building has beams. Let me just snip it to this one, to OneNote, right? So when we move here, these are the beams which we have. Okay, so these are the beams which we have, and let us probably give some dimensions for these beams, and okay, it's not 1 minute please. Right, so if you see over here, let's have this beam as 0.25 by 0.45 deep. Okay, and let us keep, because if you see the span is very less, it cannot be too deep. And other one, the beam over here, we will have this beam as 0.25 by 0.6, and there are some secondary beams over here. We will have this as 0.25 by 0.3. One of the important thing is, you should never have a secondary beam deeper than the primary beam. But one very important thing is that these will not be called secondary beam because they are framing into columns. I'm sorry, I forgot. These are actually framing into columns. So these will be primary beams, and because the span is large and it's again going to frame into the what you call as the this one. If this beam is 0.6, this will have to be actually deeper. Okay, because here I see there's an intermediate beam. So let me have this as 0.6 and that one as 0.5. Okay, now these beams are expected to span across the corridor. What we did is we made the depth of the beams in the corridor lesser. So this beam was 0.25 by 0.3. Okay. Now most of the beams are taken into account. We are not taking into account right now staircase and associated. Okay. Now let the slab thickness is 0.125. So here if you see, the overall span is 21 meters, and 21 meters minus 21 minus 1.75 minus 2.5 is 16.75. So this length is 16.75 meters, and the breadth of this area is, it may be faster for us to add the values between the grids. 2.4 plus 2.8 into 2. So this is 8 meters. Okay, and this is this alone, this length alone will be 2.8 into 2, 5.6 meters. Okay, now what we have done is we have got the lengths of all the beams taken out for us. Very quickly, let us give some names. So let us call it as FB1, this is FB2, FB2, FB3, FB2, FB2, and this will be FB1. Okay, and over here also we have a beam. So let me call this as FB4. The length is the same. So again this is FB4, FB4. So the rest of the beams are FB4. Okay, and here also, this side also the beams will be FB4. All the corridor beams, let us call it as FB5. Now what is the area of slab? Given the whole thing, so there is one more small projection over here. This projection is 2.6, and this dimension is 2.8 into 2. 2.8 into 2 is 5.6 meters. So slab. So let us call the this entire area slab 1. This area slab 2. We are ignoring the staircase area for the present time, because in the interest of time. So I mean, I will come to that, but you just have a look at it right now over here. So slab S1 is equal to 5.6 meters by 5.6 meters by 16.75, and the depth is 0.125 meters. And what is going to happen, how many numbers of slab is there? The number of slab is 1, only one number is there. So this is this part is taken care of. This part is the between grid D and F is taken care of. Between grid C and D is S2. I am again going to call it as one number, and this one is going to be 21.05 minus 1.75, which is 19.3 meters. It is 19.3 meters long, and the breadth is 2.4 meters across. Again the depth is 0.125. This area I am calling as S3, and that is one number into 2.6 by 5.6 into 0.125. Okay, now if you look at it, this is actually going to be the, when I'm looking at only the areas, that is going to be the floor area of the entire place. I am sure you'll agree on this part. Okay, and when you multiply these values, you will get 5.6 into 16.75 into 0.125. This is 11.73. Again the unit is meter cube, and 19.3 into 2.4 into 0.125, which is equal to 5.8, and 2.6 into 5.6 into 0.125, which is 1.82. So the total concrete which you are using for the slab alone is 11.73 plus 5.8 plus 1.82. So this is 19.35 meter cube. Okay. Now, if you look at it, if suppose I'm having the plan area of the place, immediately I can say for slabs I need 19 into multiplied by the thickness of slab. It can be 0.15 or 0.125, 0.115, depending on your experience, the material, and also the amount of reinforcement which you're placing, the values come. Okay. So now when I look at it, so also for beams we will be getting the values. So for FB1, how many FB1 is there? How many FB1 do we have? FB1 is 1, 2, 3, 3 numbers into 0.25. Actually, I should have put that in the last, but anyway, give or take, don't worry about this. And multiplied by 5.6 into, um, let me just move the whole thing up a little. Right. So, FB1 is equal to 3 into 0.25 into 5.6 into one more term into, wait, this is not the right way to do it, for the simple reason that I'm not keeping the length and breadth and depth correctly. Okay, so I'm not happy with the way I'm doing it. Let me redo it. So length of the beam is 5.6 meters, and then the breadth of the beam is 0.25, and the depth of the beam is 0.5 meters. Okay, and so on. FB2, 1, 2, 3, 4. There are 4 numbers of FB2 of length 0.65, of width 0.25, and depth 0.6. Right? And then we are having FB3. FB3 is equal to one of the reasons why we need to break FB3 is because the concrete of the column has to be reduced from the length. Okay, and then only we can take it into account. But in any case, we are not going to be able, we are not detecting the concrete of the column for this particular case, mainly because in the interest of time. Okay, so if you are doing a more accurate calculation, it is expected that you remove the concrete which is there in the column. Okay, and FB3, when I take it, there is actually one 0.6 column, another 0.6 column. So when I look at it, it is from my heart I'm not able to continue without taking the detection. So maybe I should probably do it. So 1 into, here it will be 5.6 minus, see this is 0.6 column, and then we are having a 1.25 on both sides getting cut. Okay, so 5.6 minus, I mean that will not come into the picture itself. So 0.6 minus 0.125, 0.475 into 2 minus 0.95. So, and then again there is a 0.3 which is here, which is not part of this column, minus 0.3. So now you will see that the amount of what we call as, suppose we are not taking into account the the deductions, you'll find that the value which is coming is very large. Okay, so in fact it's slightly more, 6 minus 0.25, because when I'm looking at the column, the grid line is over here. So here there's a 125 mm, and on the other side where I mirror also there is a 125 mm. So 0.25 goes out of that, and whatever remains of that is the it is what is that. So 1.2 minus 0.25 is 0.95. So this entire thing is, so these two things put together is this 0.95. So you can see how much of extra length is likely to be taken when you just take the value. Okay, now yeah, and then I am going on into 0.5. Again, the depth of these FB3 was 0.5. Okay, so when you keep adding all of the concrete elements, you'll find that you are able to get a sum. Okay, now these values, when you add up, you will find that you are getting a certain number. So let us say that you got the concrete value as x. Then I can say the concrete quantity required for beams. This is the approximate method of working. Okay, what we'll do is for beams, the value is equal to x divided by floor area. So same thing I can do for column. Column, it requires y divided by floor area. Okay, now y divided, what do you mean by y divided by floor area? This value which we had got earlier, 20. Okay, then footing, we got footing is equal to z divided by floor area, and I can actually add all of these values. So what actually happens is I get a thickness, so many meter cube per meter cube of concrete. Okay, so this is an example of an approximate method of estimate. So what we do when we do multiple buildings, we get an index. So this index is a value which you are sure that would be the quantity of the material, I mean, for example, in this case, concrete, which will be used for a type of building. So, when I am going to take a beam, I will say that for this building, the thickness of concrete which will come will be a value. I am just putting it as small x. For this particular building, columns will take y, and footing will be taking z. And already we know that we are going to use a certain thickness of the slab. So when I'm going to say, like for example, I can add lintel, sunshade, lintel plus sunshade probably, okay, and then say this is small l. So for this floor area, the entire volume of concrete divided by this number will be approximately so many meters, x meters, y meters, z meters. So when I want the total concrete quantity, all I have to do is x plus y plus z, which you know from experience, plus L will be the thickness of the concrete. So let me say it as C, and floor area into C will be the total concrete. So if suppose you work in a design office or you have been working in site, you will need to try and evaluate all these indices for your particular type of projects. For example, if you take a building, if the building is more or less rectangular, squarish, you will find that the value of x, y, z and L will not change much, provided the type of building is the same. So you build one residential complex, get all these indices in place, try to estimate what could be the work for a what would be the amount of concrete which will be required for a other residential project. You cannot take a residential project and then compare it with some other project which is not similar to this one. Again, this will work only if suppose the seismic zone and other design parameters are same. So if suppose the design parameters are the same, then these indices will work. If suppose something changes, columns could become more stocky. It means that whatever we have taken as y, the y will be slightly more. So when you are able to, but if you are a builder probably working only in a city like Chennai, you will know that you will be very confident that your estimate is not going to be off. So this is the way by which we develop what we call as indices for our structures. Okay, this is an approximate method of doing the estimate. So it'll have a slight give or take. Okay, for example, from your experience, you know how much wastage is going to be there. That much of work you will automatically be adding. I mean, actually, my aim was to make sure that we get values for all the numbers and then work out x, y, and z. But in any case, I'm going to probably leave this as a assignment for you to try and work out. All the dimensions are available for you. Put it together. Okay, remember that this is a two-story building. So whatever is the quantity of beams which are for, what is the concrete quantity you're getting for beams, ensure that you multiply it by the number of floors. Column we have already taken from ground floor to the top, so you don't have to worry. Slab is outright, you can tell 0.125 into 3, because for the ceiling, slab over first floor, slab over ground floor, 3 slabs you are going to require. So all the three are, all the 3 slabs are under your, will require that much of concrete. Okay. And of course, usually the waste slab is around 0.25 in a in a staircase. You will need to remember that there is a slope of the staircase. Okay, there are landings and slopes, so you will need to take that a little carefully. Okay, and yeah, any question in this approximate method which we discussed today, please? Let me open the, let us just keep the floor open so that any of you who has a doubt can please ask.
Yes, sir.
Yeah, can you just summarize what we saw today? Did you understand what has been told?
Sir, making a detailed estimate.
Okay,
Instead of making a detailed estimate, we are making an approximate estimate.
very good. By generating indices. Okay, so
Yes.
I will probably ask. Can you just give us a brief idea on what we mean by the word index or indices?
Sir, not taking it exactly, but by taking the meters and dividing the area to achieve the.
Yeah, so it is like saying that approximately when I go to a particular shop, maybe I'm going to Subway, I'm going to spend 500 rupees per person. Are you able to get it? That is the gut
Yeah.
feeling which you should have when you are having this value. How do you know that you're going to spend 600 rupees on a person when you go to Subway? You've already gone to Subway and eaten, right?
Yeah.
So when I go with my family, I know, okay, so many what do you call as, gentlemen are there, so many ladies are there, and so many children are there. So approximately for each child, I'll be spending a certain amount of money. For each of the women who accompany us, they may like to have, you know how to kind of gauge the mood, and then based on that you get the value. So will the same value hold good if you're going to some other hotel?
No, no, sir.
It will be definitely different. That is what I want you to remember when I'm talking about indices. The index could be the same when the building is similar, when the site is similar, and everything is alike. Okay, so basically what we have done here, we have used what we call as a thumb rule. We try to develop thumb rules where we give everything in terms of height of concrete. Okay, and we simply multiply by floor area to get the values. Okay, so thanks a lot for joining, and friends, thanks for a very accurate description of what we are doing. I hope you all found this session useful, right? And although we didn't finish the problem fully, I am sure that all of you will be able to complete whatever was left. You will be able to do it, am I right? Okay, guys, you need to try it out. If you try it out, I'm sure that you'll be able to work it out. So, in any case, you'll be getting the video of this lecture very shortly. Just go through the dimensions and other things which we are sharing, and attempt it. Please attempt it. And this is what you will be doing whenever you go out of these four walls. Okay, although it doesn't sound very attractive and glamorous, this is the main lifestyle of all the civil engineers, at least today. Slowly, the Revit model which I showed you is going to give all the values, okay, but you will still need to have the gut feeling that this is the value which is going to come. Computers usually make the brain a little idle, although you get to do wonders. So in any case, please make sure that you are able to get these indices right, because this was the strong point of all my bosses. They did everything by hand. So when we make a mistake, the moment we show it to them, they'll know, John, this is the place where you made a mistake. I still remember my boss TV. We went with Excel, we went with Stat Pro. It was no, we are right. He took the back of his envelope, really a back of the envelope, and started to write down numbers. John, what is this number? I'll tell. Okay, so after I gave the list, he told John, this is the place where I made mistake. Go and check. And it was right. So his name is Mr. T Venkatesh Rao, and he was one of the best bosses under whom I worked. So I'm very happy to share that also with you all. Anyway, guys, thanks a lot for joining. I know we have extended the time by about 3 minutes, and I really thank you all for your patience. And if you have any questions, you please ask. I'll be with you for a couple of minutes, maybe 5 minutes or so. I'll be happy to answer your questions. In any
Hello.
case, we will also meet in the next session. The next session will be covering a little bit more, where we'll be talking about some of the things about steel structures and the indices which you can get for steel structures also. So thank you, and I'm sorry. So one of you was starting to say something. I'm sorry I interrupted you.